Today we're looking at notes 7-9, solve exponential and logarithmic equations. So the first thing we're going to do is look at solving exponential equations. So if x is in the exponent, the first thing you're going to do is isolate the base, convert to a log, and then use your calculator to solve. So for example, looking at number 1 here, I've got x in the exponent and 5 is my base. I want this base of 5 with the exponent of x to be isolated. So that means I need to get rid of the plus 1. So I will subtract 1 from each side. So then I get 5 to the power of x equals 18. Once my base is isolated, then I'm going to convert to a log. So using the swirl process, I would go like this. It's an exponent, so the first thing I'm going to do is write log. The base of my exponent becomes the base of my log. Log base 5 of 18 equals x. And then I'm just going to use my calculator to solve. So I'm going to open up my calculator, do alpha window 5. Log base 5 of 18 is 1.80 if I round to the hundredths place. So x equals 1.80. Okay, doing another one. Here I've got x in the exponent. My base is 3. Okay, so what directly is in front of it is my base, so my base is 3. So I need to get this whole thing all by itself. That means I'm going to add 5 to both sides first. So add 5, add 5. Okay, then I get 4 times 3 to the 2x minus 1 equals 15.84. Then, in front of this base of 3, I've got a multiplication of 4. To get rid of that multiplication of 4, I divide both sides by 4. So I get 3 to the 2x minus 1 equals 15.84 divided by 4, which is 3.96. All right, and now that I've got my base isolated, I'm going to convert to a log. So log base 3 of 3.96 equals 2x minus 1. So I'm going to type into the calculator alpha window 5 log base 3 of 3.96, which is about 1.25. So I would have 1.25 equals 2x minus 1. Then of course I need to add 1 both sides, so I get 2.25 equals 2x. Divide by 2, divide by 2. 2.25 divided by 2 gives me 1.125. So about 1.13 is what x equals. Okay, maybe one more example of this. Example number 3, 5 to the 3x plus 2 equals 8. Okay, again, get that base with the x as the exponent by itself. So subtract 2 from both sides. So I get 5 to the 3x equals 6. Okay, then I need to convert. So log base 5 of 6 equals 3x. Log base 5 of 6. Log base 5, 1.11. 1.11 equals 3x. Divide that by 3. I get 0.37. Divide 3, so 0.37 equals x. All right, let's move on to, that was solving exponential. Now let's talk about solving logs. So if x is inside the log, you're going to first condense to a single log, isolate the log, just like we isolated the base before, make the coefficient of the log 1, convert to exponential, and solve. So it makes sense. If you've got exponential, you convert to log. If you've got log, you convert to exponential. They're inverses of each other. Okay, so example number 1 for the log, we have 3 times log base 4 of x minus 2 equals 3. So, condense to a single log. Done. I've only got a single log here. Isolate the log. Well, then I need to get rid of this 3 out in front. So I'm going to divide everything by 3. Okay, so those cancel, and we've got log base 4 of the quantity x minus 2 equals 1. The log is isolated, okay? There's nothing in front or behind. This is in parentheses, so we leave it alone. The coefficient for the log is 1. Convert to an exponential. So this would be 4 to the first power equals x minus 2. 4 to the first power is just 4. So 4 equals x minus 2. Add 2 to both sides. You get 6 equals x. And you're finished. All right, let's look at another example. Example number 2. 2 log quantity x minus 1 equals 1.5. Okay, again, condense to a single log, but that's already done. All right, so then we need to isolate the log, nothing in front, nothing in back, making the coefficient 1. So that means on this one I need to divide both sides by 2. Okay, so log of x minus 1 equals 1.5 divided by 2. So 0.75. Okay, now that the log's by itself, nothing in front, nothing in back, I can convert to an exponential. Don't forget, no base written, 10 is implied. So 10 to the 0.75 equals x minus 1. Okay, so 10 to the 0.75 is approximately 5.62 equals x minus 1. Add 1 to both sides, I get 6.62 equals x. Okay, now let's look at 2 more examples where you are in fact going to have to condense to a single log. So log of x plus log of 4 equals 2. Okay, so when there's a plus in between, remember when I'm condensing to a single log, that means multiplication. So this would be log of x times 4, which would be 4x, equals 2. So log is isolated. We're going to convert to an exponential. So 10 squared equals 4x. So 100 equals 4x. Divide both sides by 4. You get 25 equals x. All right, last one. Number 4. I've got log of x minus log of 3 equals negative 1. There's a minus in between these logs. When I condense to a single log, that means this would look like log of x divided by 3 equals negative 1. So now I've got a single log, nothing in front, nothing in back I need to get rid of. 10 to the negative 1 equals x divided by 3. 10 to the negative 1 equals x divided by 3. By now you should surely know that 10 to the negative 1 is 1/10. So 1/10 equals x over 3. Cross multiply. 10 times x equals 3 times 1. So divide both sides by 10. You get x equals 3/10, or x equals, well, just leave it as 3/10. You can make it a decimal, but 3/10 is fine.